All right, what is going on, everybody? Hope y'all good. Just want to do a quick little basic video on sequences, which would be 12.1 from our book if you want to know. Go ahead and read the definition there, and let's check out an example sequence. So I'm just going to put on here 1, 1/2, 1/3, 1/4, 1/5, and da 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 da. These things are called ellipses. Remember, that just means this pattern, this sequence would continue on forever. Let's go back and look at the definition. Function whose domain is a set of positive integers. Remember, integers are like 1, 2, 3, 4, 5, and you guys can see these are not integers. So what is going on with that? Well, I will tell you. Remember, this is a function whose domain, remember, domain means input values. So if I put in a positive integer, I should get these numbers back. So this sequence is actually written as 1 over n. So example, if n is equal to 1, I get the first term. If n was 2, I get the second term. If n was 3, I get the third term, so on and so forth. Um, Here's what I want you to know from this. Just some quick notation. Like if I said a sub 3, that's talking about the third term, which in this case would be 1/3. Or a sub 1, that is the first term, which in this case would be 1. Okay. This guy right here is called the explicit formula, because I could literally ask you for any term and you could find it. Like if I said, what's the 20th term? A sub 20, you would just plug in 20 for n. So in this case, 1 over 20. Okay. Here's what you guys are going to be doing with this. Got a couple examples. So write the first few terms of this sequence. So always start with n equaling 1, and then plug in 1 and see what you get back. So 1 minus 1 is 0, divided by 1, 0. And then plug in 2. So 2 minus 1 is 1, and n is 2. Plug in 3. Plug in 4. And then so on and so on. This just said first few, so that's good. Let's check this guy out. Same story, though. Plug in 1 to begin. So negative 1 to the first power. This is a negative value. And then 1 plus 1 is 2. So negative 2. Plug in 2. Negative 1 squared. This would be positive. And then 2 plus 1 is 3. And then where am I at? 3. So negative 1 cubed. This would be negative. And then 3 plus 1 is 4. And then you can see the pattern from there. And that's good for that. Okay, and then the last thing, something called a recursive formula. You remember earlier I mentioned the explicit formula, because you can plug in any number and get any term. With a recursive formula, you need the previous term to get the next term. So here's the example. I give you the first term, and I want the first 5 terms. Okay, so check out how this would work. A sub 2, my n value would be equal to 2. So that's a 2. And then this says a sub n minus 1. In this case, if n is 2, I got 2 minus 1. So this is technically a sub 1. And then that was given to me. So this is 2 times 1, which is 2. Okay. For a sub 3, let me erase this guy here. My n value is 3. And then this would become a sub 3 minus 1, which would be a sub 2. Which in this case, remember, a sub 2 is equal to 2. So this is 3 times 2, which would be 6. Okay, so hopefully you guys are seeing that, how I'm using a previous term to get the next term. So if I want a sub 4, I'm going to use a sub 3, which is 6. So that's 24. And then a sub 5, this is going to work out to just be 5 times a sub 4, which is 120. Cool, guys, nice quick little video. Don't forget to hit subscribe and smash that like button.